When it comes to the practical matter of dealing with electricity in your home, you really just have to remember 3 words.
Hot, neutral, and ground.
And 3 colors.
Black, white, green, and copper. So there are really 4 colors.
Oh, and you forgot red. But we'll get to that later on. These terms and colors are standard in all new wiring across the country. The hot wire brings the current out from the source. This wire is most often wrapped with black insulation. Once electricity has done its work, it goes back on the neutral wire, which is most often white.
The ground wire offers current another path to ground in addition to the neutral. The ground wire is always either enclosed in green insulation or is bare copper.
When you flip a switch, you actually complete a loop that starts at the power source, flows through the hot conductor to the light bulb, back to the power source through the neutral conductor. Now there are several devices designed to stop the flow of electricity between the power company and the light bulb should something go wrong. The most important of these are your home circuit breakers. A breaker is designed to turn the power off to trip should too much current try to flow through it. This protects circuits, appliances, and people. For example, if the hot lead and the neutral lead were accidentally connected, it creates a situation called a short circuit. Current will take the easiest path available to it, so it'll bypass the bulb and take the direct route back to the neutral, the short circuit. However, there are cases where a short circuit is preferable to an even more dangerous situation, and this is where the grounding system comes in.
Well, suppose the hot lead in this toaster came loose and accidentally touched the metal case. This makes the outside of the toaster electrically hot, and there's a real risk of fatal shock for anyone who touches it.
A grounding system connects the metal frame and case of the toaster to the earth. If a hot wire touches a toaster frame, it immediately creates a short circuit and trips the breaker.
Short circuits aren't the only reason for a tripped breaker. Overloaded circuits are actually an even more common cause. Well, each circuit in a house is designed to carry a maximum load, depending on the area of the house or which appliance the circuit feeds. On our demonstration service panel, the main breaker is rated at 100 amps, and there are 15, 20, 30, and 40 amp breakers for various circuits. If too many devices are running on a circuit, it draws more current than the wiring is designed for, and the breaker will trip, shutting down the circuit. If an older house has been remodeled or large appliances have been added, you may find several types of service panels. You may also find fuses instead of breakers. Cartridge fuses are used for the main and for large appliances, and screw-in usually service the general circuits.
Now we want to cover some of the basic steps of wiring encountered in an electrical rough-in. For that, we've set up a demonstration area with the kind of framing you'll find in new construction. The electrical rough-in is done after the heating and plumbing rough-ins. This is because it's easier to run wires around pipes and ducts and vice versa.
The first step in roughing in is to install all the boxes where there will be lights, switches, outlets, or wire junctions.
There are literally hundreds of different types of electrical boxes. The most common used in residential wiring are non-metallic boxes like these. They've got small spacing tabs on the sides so you can position them on the studs to end up flush with a 1/2-inch drywall that will be attached later. They also come with nails on top and the bottom to help secure them to the studs. For countertop outlets like these, we set the tops of the boxes 46 inches above the floor so the outlets will be pretty much centered between the counters and the upper cabinets. Codes require that there be at least one outlet for any countertop wider than a foot, and that outlets be spaced so that no point along the back of the countertop is more than 24 inches from an outlet. The boxes come in different sizes depending on the number of switches and outlets, as well as the number of cables running through the box. So you need to plan your runs carefully and buy the right size for each location. Because the sheetrock on the ceiling is a little thicker than the sheetrock on the wall, I'll need this box for the overhead light to hang down just a little further. There's a little margin for error here, so I just eyeball it 5/8 of an inch out. This box nailed into the side of the joist. This box, which is also common, has metal supports that allow you to position it in between the joist.
Once all the boxes are installed, you can drill holes through the framing for the wiring.
To run wires through the wall studs, the holes generally go about knee height, and code requires that the holes be at least 1.25 inches from the front of the stud and 1.25 inches from the back of the stud so that the cables running through the holes won't be pierced by any drywall, screws, or nails. It basically means drilling the holes dead center. By the way, cables are always easier to pull through later if the holes are all the same height. Existing mechanical runs might not let you drill the holes dead center, but you can still protect your wiring from nails and screws with these steel plates which are available at home centers. Code requires them to be at least 1/16 of an inch thick, and you must use them whenever a hole is less than 1.25 inches from the edge of the framing. Depending on the layout of your project, you may find yourself drilling through ceiling joists. Even on thicker lumber, try to drill in the center of the piece.